Okay, so here we have the ladder which is 15 feet in length, and this is leaning against the wall. And this point B represents the top position of the ladder, and the point A represents the bottom position or the foot of the ladder. And this top slips down at a rate of 2 feet per second. So that is represented as dy over dt is negative 2 feet per second. Since it is slipping down, I have put this as negative. And at some point of time, the top position is at a distance of 13 feet from the base of the or from the ground. And in that situation, we have to determine the rate at which the bottom position of the bottom of the ladder is moving away from the ground or the base of the wall. So let's see how to determine this. First, when I consider this right triangle, that is triangle OAB, we can apply the Pythagorean theorem here. That is OB squared plus OA squared, and this equals AB squared. Let's substitute the values of OB. OB is basically the distance of the top of the ladder from the ground, which is about 13 feet. So I put 13 square plus OA. We have to find this distance, and this equals AB is 15. So it is 15 square. So let's determine OA from this one by subtracting 13 squared. So this equals 15 squared minus 13 squared. So we say OA equal to square root of, we have to take the square root, 15 squared minus 13 squared. And this equals 15 square is 225 minus 13 square is 109. So when you find this, we get square root of 56. This OE basically represents the distance of the foot of the ladder from the base, which we can represent as x. So I'm going to consider this OE as x, and this is in feet. Now, once again, we can consider the right triangle. And this time, I'm going to write down in terms of equation, that is x squared plus y squared, and this equals 15 is the hypotenuse, so it is 15 squared. Now we are going to find the derivative on both sides. So we find the derivative with respect to x on both sides. The derivative of x squared is 2x dx over dt. We find the derivative with respect to time, and plus we find the derivative of y squared with respect to time. So once again we put to y, and then we have to apply the chain rule to find the derivative of y with respect to time, which is dy over dt, and this equals this is a constant, so it's going to become 0. And we see that we have the common factor 2, and this means we can divide both sides by 2, so therefore this 2 gets cancelled, and 0 by 2 is also 0. So this simplifies to x times of dx over dt plus y times of dy over dt, and this equals 0. Now let's substitute the values which we have found as well as given in this question. We have found this x when y equals 13 feet. So let's put the value of x as square root of 56. So this is square root of 56 times dx over dt. We have to find this. So I write down as it is plus y. The y is given as 13 feet. So I put 13 here times dy by dt, which is given as negative 2 feet. So I'm going to put negative 2, and this equals 0. Now we can solve for dx by dt from this. So I write down this root times of 56 times dx over dt. 13 times negative 2 is negative 26, and this equals 0. So we can add a 26 to both sides. So therefore, if we rewrite this equation, this will become equals positive 26. Now we solve for dx by dt by dividing both sides by root 56. So therefore, we get dx over dt, and this equals 26 over root 56. We plug this expression into the calculator, and when we do that, we get approximately, this is 3.47, and its unit is feet per second. So we now see that the foot of the ladder is moving away from the base of the wall at a rate of 3.47 feet per second.